Aluminum-ion batteries promise to fully charge in just 15 minutes. A feat that makes them 20 times faster than current lithium-ion batteries. Imagine pulling into a charging station, plugging in your car, and being back on the road before you've even finished your coffee. For drivers who've grown accustomed to the slower charging times of lithium-ion systems, this change transforms EV ownership into something far more convenient and practical. It's a leap that could make charging your EV feel as seamless as refueling a gasoline car, eliminating one of the last hurdles holding back widespread adoption. Speed, however, is only part of the story. Aluminum-ion batteries also boast an impressive energy density of up to 1000 Wh per kilogram, a significant improvement over the 4680 batteries maximum of 280 Wh per kilogram. This leap in energy density means that vehicles equipped with aluminum-ion batteries could achieve ranges of up to 2,000 miles on a single charge. An astonishing figure that makes even the most ambitious lithium-ion systems look outdated. For drivers, this translates into fewer charging stops and the freedom to take long road trips without the constant worry of running out of power. Durability is another area where aluminum-ion batteries excel. These batteries can support up to 15,000 charge cycles with proper management, significantly outlasting the lifespan of lithium-ion batteries. To put that into perspective, a car powered by an aluminum-ion battery could remain operational for over 20 years without requiring a battery replacement. This longevity not only reduces costs for drivers, but also minimizes the environmental impact of producing and disposing of battery materials. It's a win-win that aligns perfectly with Tesla's commitment to sustainability. Previously, we touched on the safety concerns surrounding lithium-ion batteries due to their flammability. Aluminum-ion batteries address this issue with their non-flammable design and exceptional stress tolerance. This makes them far less prone to the overheating and thermal runaway issues that have plagued lithium-ion systems. And the standout feature of aluminum-ion batteries lies in their sustainability, perfectly aligning with Elon Musk's vision of creating a greener, more sustainable future. Aluminum is one of the most abundant elements on Earth, making it a far more accessible and cost-effective resource than lithium. Its abundance not only reduces production costs, but also alleviates the geopolitical and environmental challenges associated with mining rare materials like cobalt and lithium. Additionally, aluminum is highly recyclable, ensuring that these batteries align with Tesla's mission of creating environmentally responsible solutions. By shifting to aluminum-ion technology, Tesla isn't just making EVs more efficient, it's making them sustainable. It's worth noting how aluminum-ion batteries connect back to some of the challenges posed by lithium-ion systems. While the advantages of aluminum-ion batteries are clear, of course, no technology is perfect, and aluminum-ion batteries do have their challenges. The promise of faster charging, greater range, and improved sustainability is exciting. But it also raises questions about the technical hurdles that remain. Can aluminum-ion batteries achieve the high voltage required for demanding EV applications? How Tesla plans to tackle them? Can this promising technology truly live up to its potential? Aluminum-ion's toughest roadblocks. While aluminum-ion batteries promise to revolutionize the EV industry with their speed, safety, and sustainability, the challenges are also real. A key challenge that stands out is the voltage limitation of aluminum-ion batteries. Currently, these batteries generate only about half the voltage of their lithium-ion counterparts. Voltage is a critical factor for powering EVs as it directly impacts the battery's ability to meet the high demands of electric motors. While aluminum-ion technology excels in energy density, its lower voltage output means it struggles to deliver the same level of performance required for today's electric vehicles. This limitation underscores the need for further research and development to bring aluminum-ion batteries up to the standards of commercial EV applications. Beyond just voltage limitations, there are technical hurdles to overcome, particularly in the design of the battery's internal components. The use of advanced materials such as nanostructured cathodes is essential for improving the efficiency and performance of aluminum-ion batteries. These cathodes allow for better energy storage and faster charging while minimizing the degradation that occurs over time. However, developing these materials at scale is a complex and costly process. Researchers are actively exploring ways to refine the technology, but significant investments in material science and engineering are still needed. Scaling production is another significant challenge. While aluminum-ion batteries hold great promise, their manufacturing processes are far more intricate than those of lithium-ion systems. For instance, the production of nanostructured cathodes and advanced electrolytes requires highly precise techniques that are not yet widely available. Tesla's ability to meet its ambitious production targets for vehicles like the Model Y will depend on whether these processes can be streamlined and scaled efficiently. Without this scalability, the cost of aluminum-ion batteries could remain prohibitively high, slowing their adoption in the EV market. On top of that, the potential success of aluminum-ion batteries is closely tied to the strength of their supply chain. While aluminum is abundant and cost-effective, transitioning to a new material base involves reconfiguring existing supply chains and manufacturing infrastructure. Tesla will need to ensure that its suppliers can meet the quality and sustainability standards required for aluminum-ion production. At the same time, the company must navigate potential bottlenecks in securing advanced materials like organic redox polymers and nanostructured components. Despite these challenges, there are reasons to remain optimistic. Tesla has a history of tackling complex problems and delivering innovative solutions, as evidenced by the success of its 4680 battery. The lessons learned from overcoming the limitations of lithium-ion technology could serve as a foundation for addressing the issues with aluminum-ion batteries. For instance, Tesla's dry electrode manufacturing process developed for the 4680 may provide insights into how to streamline the production of aluminum-ion batteries. It's also worth noting that many of these challenges are not unique to aluminum-ion batteries. Voltage scalability and supply chain issues have all been hurdles in the development of previous battery technologies, including lithium-ion systems. The fact that lithium-ion batteries evolved to meet the demands of modern EVs suggests that aluminum-ion technology could follow a similar trajectory with the right investments in research and infrastructure. Taking stock of what aluminum-ion batteries offer, it's clear that the potential rewards justify the effort. These batteries offer a combination of features: faster charging, longer lifespan, and greater sustainability that address many of the shortcomings of lithium-ion technology. For Tesla, overcoming the challenges of aluminum-ion batteries isn't just about improving performance. It's about leading the way of sustainable transportation and solidifying its leadership in the EV. As Tesla continues to refine this technology, the stakes couldn't be higher. Aluminum-ion batteries represent not only a leap forward for Tesla, but also a potential game-changer for the entire EV industry. They have the power to set a new standard for what electric vehicles can achieve, from extended range to faster charging and beyond. However, before they can fulfill this promise, these challenges must be met with innovation, collaboration, and determination. Despite these obstacles, the next chapter, the potential impact of aluminum-ion batteries on the EV industry, is monumental. If Tesla can successfully address these challenges, this technology could redefine electric vehicles, making them more efficient, affordable, and accessible than ever before. The last thing that needs justification is how aluminum-ion batteries could revolutionize the 2025 Model Y and transform the EV market as a whole. Could this be the breakthrough that propels electric vehicles into a new era of dominance, the next chapter in EVs? The potential impact of aluminum-ion batteries on Tesla's 2025 Model Y is nothing short of transformative, with groundbreaking features like extended range, faster charging, and unmatched longevity. These batteries promise to redefine the electric vehicle experience and set a new standard for the industry. But what makes this innovation so revolutionary? And how will it redefine the future of EVs? To better understand this, imagine driving an electric vehicle covering up to 2,000 miles on a single charge. That's the kind of range aluminum-ion batteries could offer, dwarfing the current capabilities of lithium-ion systems, which typically top out around 330 amp per charge in Tesla's Model Y. This improvement in energy density up to 1,000 Wh per kilogram represents a leap forward in battery technology. For drivers, it means fewer stops on long journeys and the freedom to travel vast distances without constantly planning for charging stations. It's a solution that directly addresses one of the most common concerns for EV owners: range anxiety. From a very young age, Celine Tam's world revolved around music. Born in Hong Kong to a family that deeply valued the arts, her father, Dr. Steve Tam, recognized her extraordinary potential almost immediately. By the time she was just 3 years old, she was already singing along to songs by her idol, Celine Dion, the artist who would inspire her name and her dreams. Her father, who worked as a vocal coach, began nurturing her raw talent, guiding her through the basics of vocal training and introducing her to the techniques that would one day wow millions across the globe. It wasn't long before Celine began performing publicly, charming audiences in local events and competitions with her stage presence and a voice far beyond her years. Her big break came when she auditioned for America's Got Talent, a moment that would change her life forever. Standing on that grand stage, in front of millions of viewers and the notoriously hard-to-please panel of judges, she performed with a grace, control, and emotion that astonished everyone in the room. Her rendition of My Heart Will Go On earned her